it seeds globally as well as in Pakistan. For us, I work in the social sector. I work with farmers, and my organization works with farmers, landless and small farmers. And so the issue for us is actually beyond technology, also a political question of what does genetically modified food. 50% of the working population in Pakistan, and they are all dependent on the availability of natural resources, including seeds. And then now we come to the political arena, which is the question of intellectual property rights over seeds, which is a conditionality of the WTO and also of the global system. Where now they are saying that seed is a material and can be owned by individuals. No, in Karachi, 60 women died in a food shanty, which shows very concretely that people are looking for food. There are long lines outside the subsidized food systems, outside the utility stores, and 70% of our population living in the rural areas is now suffering from malnutrition. And these are facts and figures the UN and the FAO are giving about Pakistan, and it's easily available. Secondly, we really think in terms of water. Water is now a scarce resource in Pakistan. The constant conflict between Sindh and Punjab is based on water, and as the years go by, there will be increased scarcity of water. Land issue, we already know land reform data is from a corporation, it's an investment corporation called Shoulders, and they're talking about one invest in agriculture. They're saying that the world population is rising, and then they show Asia and Africa showing that populations in both the biggest continents now is increasing very sharply, which basically means that with increased population there will be more need for food. Consumption has gone up, whether it's corn or meat or whatever, there are high consumptions, which also means that with more people, more consumption, food will become a commodity and will become more and more expensive. And then this is very dangerous. It shows that the food stocks are going down. Worldwide, food stocks are going down. All of this, when a corporation like Schroeder is talking about food as a market commodity and is looking in the context of investments, it means that for them, growing food is based on profits. We as a third world nation, suffering from scarcity, has to look at food as a basic right. We cannot think of food as a profit-oriented commodity, which is what is happening at the global scale. And now Schroeder is, and there are many, I just pick up one, there are many investment corporations looking at agriculture in the context of profits. What does it mean? It means that in Pakistan we have corporate farming ordinance passed in 2001, which is allowing massive lease of land to foreigners. Everybody is talking about the 500,000 acres of land with Pakistani government is negotiating with the Saudi Arabian government. There are others, and in the media they are saying nearly 6 million acres of land is out for leasing. In the same context, we are also talking about BT cotton. The Pakistani government has allowed Monsanto to start field experiments in Pakistan and increase the production of BT cotton, which means less land for food. It also means that the control of seed is now going to be in the hands of big corporations coming from the north, whether they are American or whether they are European. I just wanted to set a context to look at the technical issues. It has to be looked in the context of seed. So, because Dr. Henson is not from Pakistan, and the political context of the argument, especially in the academia, has to be both technical aspects as well as political. So I just wanted to set that kind of frame of reference, and I will end here. Thank you very, very much.
Dr. Azantala. Now I'd like to invite Dr. Michael Hansen for his talk on this very, very important issue as highlighted by Dr. Azra. He has a different view as he is coming from some other part of the world. And our perspective and his perspective may match here at some point. Please, Dr. Hansen.
That's a general case of a category of things that are called safety crops. They all raise similar issues. There's actually, I will talk about some of the potential health implications of these safety crops. But what I'd like to do is go through the basics of biotechnology. The fact is that happen because of the way we use genetic engineering, basically the insertion process. Then before I talk about the crops, I'll go through data, since one of the main arguments that's used about why this crop is beneficial is that they're good for the environment because they reduce pesticide use, and so I will go through all the data from the United States that looks very carefully at how much pesticide use has been used on engineered crops since they were first approved in 1995, China and Pakistan. So let's go through the basics and materials from one organism to another. You then replicate the DNA that replicates itself. And then DNA, the double helix unwinds, and through a process of transcription, that's read, and DNA makes a message. It's called messenger RNA, which then goes out into the cytoplasm of the cell, and through the process of RNA microRNA. So let's look. This is since late 50s is what's called the central dogma, and this is the idea. This is the idea that there's a one-way flow of information with a genetic material, with DNA, basically making RNA, a messenger RNA, the process of transcription, the message then going out into the cytoplasm, being translated into a protein, which gives rise to great traits such as eye color, such as resistance to herbicide. And it was thought for a number of decades that this is a one-way flow of information. That basically the DNA codes everything that determines a trait. We now know that the reality is far more complicated, and in fact, rather than being a unidirectional flow of information, it's actually bidirectional. So that means information from the environment can feed back and affect proteins, which can affect RNA, which can affect DNA. And it's a much more complicated process. So this notion of a one-way flow of information and then a gene that will always create the same product is not true. It's an oversimplification. This is just a pictorial view of chromosomes, double helix, that they have these nucleotide base pairs, creates a lot of traits. Many of these proteins are enzymes. And this is a simplified representation of where to start reading the gene. You need to have a termination sequence at the end of your transgene, basically telling the RNA polymerase when to stop reading. And most of the termination sequences that they use, the most frequent one is the NOS, the nucleotide synthase termination sequence, which comes from bacteria from the vascules. Part of the problem, though, is that that stop signal doesn't always work, so that you can often have multiple read-through events, so that you can actually get pieces of DNA that are different length, and so will go through different products. You then also, since you're only transforming individual cells and not whole plants, you have to be able to distinguish which cells have taken up the DNA and which haven't, because the process of transformation is actually very inefficient. When they were first doing this, you were lucky 1 in 10,000 cells was transformed. It's gotten up to 1 in 1,000, but still you have to have some way to distinguish a transformed cell that is a cell that's taken up the DNA that you're trying to transform, that's integrated into the chromosome, and it's actually expressing it, so it's creating the trait. It's engineered. So The marker genes, unfortunately, that they tend to use in most of the crops that are out on the market right now are antibiotic-resistant marker genes. And the reason they do that is because you're transforming individual cells, and to be able to select the cells you want, you usually put those cells out in a petri dish that has growth medium. You add the antibiotic to the growth medium, so the only cells that survive are the ones that are resistant to the antibiotic. Since the antibiotic resistance gene is tightly